to see something on this why highway curves are tilted. So, and we are going to cover these important topics. So let us see why highway curves are tilted. Okay. Okay, sorry for the delay. So you can see that on highways, if you see on horizontal curves, the roads are normally tilted like this. So what is the reason for this tilt? Yes, what is the reason for the tilt? So that we are going to see in today's session. So now, if we see on a curve, what happens whenever a body is traveling on a curve, then it experiences what? It experiences centrifugal force. So if you have a curve like this, so see this is a horizontal curve, this is a horizontal curve. So let me just draw this curve for you. Just draw this curve for you, something like this. Yes. It's a curve, something like this. And suppose the vehicle is traveling on this curve. Okay, let me just draw the vehicle, tentative vehicle. Okay, we draw a better curve. Okay, okay. Suppose this is the horizontal curve, and here the vehicle is traveling in this horizontal curve. So what happens to the vehicle? It experiences centrifugal force, which is outward. This centrifugal force is what? It is outward, something like this. So P, this is centrifugal force. This is what? Your centrifugal force, and this is outward. Now what is the equation for this centrifugal force? We have studied in our childhood that this centrifugal force is equal to, the centrifugal force P is equal to what? It is equal to mv square by r, where m is the mass, and then your v is the speed, right? V is the speed in meter per second, and r is the radius of this curve. R is the radius of this curve. Now we know that we can write down this weight. What we can write down the weight? The weight is equal to mass into g. So I can write down mass is equal to weight by g. So in this equation, I can change this equation. In place of mass, I can write down weight by g. So this is weight into speed square by gr. This is the centrifugal force, right? This is the centrifugal force. Very good, easy, nice. Now, this centrifugal force will try to push these vehicles outwards. So that will lead to what? Skidding. That will lead to what? Skidding. This centrifugal force will force this, or try to move this vehicle outwards. It's called skidding, right? So to oppose that, there will be what? There will be frictional force. To oppose that, there will be what? Frictional force. And for no skidding condition, yes, for no skidding condition, I can say to avoid the skidding, this P has to be what? Less than equal to this frictional force. This P has to be less than equal to this frictional force. So when P is less than equal to frictional force, it will lead to no skidding. So let us elaborate this equation. Let us elaborate this equation, or have some more discussion on this equation. So we saw that this P should be less than equal to F. Now what is P? We have just seen that P is equal to W, weight, speed square by gr. And then this frictional force will be what? Frictional force will be equal to the coefficient of friction into normal reaction, right? Coefficient of friction into normal reaction. So F is the coefficient of friction. Here we'll be using what? Coefficient of lateral friction. We'll be using what? Your coefficient of lateral friction. Why will be using the coefficient of lateral friction? Because you can see that the friction is developed in lateral direction. This is the longitudinal direction. This is the longitudinal direction. This is the lateral direction. So coefficient of lateral friction, and N is the normal reaction. Right? We have studied in childhood. Frictional force is equal to coefficient of friction into normal reaction. Now this normal reaction will be equal to what? The weight. Yes. This normal reaction, see, normal reaction is equal to what? The normal reaction will be, suppose these two N1 and N2 are there, two normal reaction. Suppose they combine to give normal reaction, total normal reaction will be balanced by what? Will be balanced by the total weight. Yes. So in place of normal reaction, I can write down what? Weight, right? This will be equal to weight. So here, what I can do is that this centrifugal force will be less than equal to what? The frictional force, which is F into normal reaction. I can use what? W, right? Now what will happen? You see this W gets cancelled. This W gets cancelled. So for no skidding condition, what equation we get? V square by GR should be less than equal to F. V square by GR should be less than equal to F. Now this F is very less. Okay, this F is very less. This friction coefficient is very less. It is lying between 0 to 0.15. The maximum value is 0.15. And there is no guarantee that the friction might develop or not. There is a very good chance that friction might not develop between the tires and the road surface. There might be some reasons. There might be rain, there might be some sand particles, or the tire might not be properly designed. There are many factors due to which this friction might not get developed. So if this friction is not getting developed, or the friction is less, what will happen? Then what will happen? In that case, this V square by GR will become more than F, and this will lead to what? Skidding. Right? If friction don't develop or friction is very less, then what will happen? That your V square by GR will be greater than F, and that will lead to skidding. Now this is no skidding condition. This is no skidding condition. But if your F is very less, then it might lead to skidding. So to avoid that, we have to do something. So what we do? We do this. We tilt the road. What we do? We tilt the road. This tilting is known as what? Banking of roads, and this is also known as providing super elevation. So what are we doing? We are tilting the road. So by tilting the road, what we are achieving? Yes. So by tilting the road or on the highway, on the curves, what we are achieving? Let us understand what we are achieving by tilting the road. So you see the road profile, something like this, and we are tilting it, right? We are tilting it. How we are tilting? We are raising the outer edge with respect to the inner. If you see here, this is the outer edge. The outer edge is up compared to the inner edge, right? The outer edge is up compared to the inner edge. So what we are basically doing? We are raising the outer edge with respect to what? Inner. And therefore, we can see that the vehicle is also tilted. You can see the vehicle is also tilted in this case. The vehicle is also getting tilted. So I'll just draw a tentative vehicle diagram. Okay, so these are the two wheels. I'm drawing the tentative vehicle diagram. Oh, this is not a presentation only, okay. Yeah, so this vehicle I have just drawn like this. So now you see in this vehicle what will be happening? The centrifugal force will be acting, which will be acting what? Outward like this. So I'll draw here also. You see the centrifugal force will be acting outward like this. Same I have drawn here. Okay. Then This is the centrifugal force P, suppose. This is the centrifugal force P, okay, which is acting outwards. Then there will be weight acting something like this. The weight will be acting something like this. This is the weight. So here also there will be weight acting something like this. Yes. Now see, we have tilted the rod, so we might have tilted by some angle, right? Theta. We might have tilted by some angle theta. So suppose this is that angle theta. Okay. So if we see this is tilted like this, so angle theta. So if this is theta, we know that when we are drawing a perpendicular or seeing a direction perpendicular to this inclined surface, so drawing a perpendicular to inclined surface, so this will be at theta angle, right? This will be at theta angle. If this is theta, this also will be theta. And now we will have components of weight along this direction and along this direction. So this will be, you see, this will be W cos theta and this will be your W sin theta, right? This will be W sin theta. Here also I'll draw something like this, you see, something like this, you see. Here I will have your W cos theta, this will be W cos theta, and this will be your W sin theta, right? This will be W sin theta. Now we'll have some component of P also, right, in this direction. Okay. Now see, this rod is inclined by angle theta. So here also you see, so this angle also will be theta. This angle will be theta. So this will become how much? This will become P cos theta, and along this direction there will be another component of P, and that will be how much? That will be P sin theta. That will be P sin theta. So since this angle is theta, you see, this angle is theta here. So what will happen? This is the P. This is P, centrifugal force. So along this direction there will be P cos theta, and then another component will come like this, and this will be how much? This will be P sin theta. Right? This will be P sin theta. So now things have changed a bit. The things have changed a bit. Okay, I'll just incline this little bit more. You see. Wait. Yeah, it will be in this, exactly this direction. So this will be more accurate. Yes, that's more accurate. So this is theta. So this is P, means this will be P cos theta. Yes, that is more accurate. And here there will be P sin theta. P sin theta. Nice. Okay. Similarly, here also I'll draw same thing. So here you see P cos theta, because this is theta, and then here it is P sin theta. It is P sin theta. Okay. Now you can see that this P cos theta will try to, yes, this P cos theta will try to skid the vehicle outwards, and then what will happen? This W sin theta and the friction which will be developed laterally, that will help in countering this P cos theta. So earlier you see, here it is only P cos theta. Earlier you can see when there was no tilting of the rod, then what was happening? You see, this P force was responsible for your skidding, and this P force was opposed by only the friction. There was only friction opposing the centrifugal force. Yes, there was only friction which was opposing this centrifugal force. But now what happened, you see, now what happened? To oppose this P cos theta, which is responsible for skidding, there is a component of weight W sin theta. Along with that, there is friction also. So two things are there. Earlier there was only friction. Now there is friction plus W sin theta. Now there is friction plus W sin theta. Two are there. So now For no skidding, yes, for no skidding, I can write down here, for no skidding, this P cos theta, write down this P cos theta should be less than equal to what? Your W sin theta and friction force. Less than equal to W sin theta plus friction force. So this becomes the equation now, right? Now this becomes the equation. So we'll just erase this and write down in fresh page that now for no skidding condition, this P cos theta should be less than W sin theta and F. Let's write down this equation. So now for no skidding condition, this P cos theta would be less than equal to W sin theta plus your friction force. Now, frictional force is what? Coefficient of friction into normal reaction. Now, see in this, the normal reaction which will be due to these two. This is total normal reaction. Here will be N1, suppose here it is N1, this is N1 and this is N2, right? So this N1 plus N2, which is total normal reaction. Now this is equal to what? If you see, it is balanced by what? This total normal reaction is balanced by your P sin theta and W cos theta, right? So normal reaction is here P sin theta plus W cos theta. P sin theta plus W cos theta is equal to the total normal reaction here, which was earlier only weight, but here if you see the balance, the normal reaction is balanced by what? P sin theta and W cos theta. Very nice. So now I can write down here, you see, I can write down here F into P sin theta plus W cos theta. And this equation will become, you see, P cos theta less than equal to your W sin theta plus, in place of frictional force I can write down F, then I can open the bracket, right? I can open the bracket, you see, I can open this bracket, F into P sin theta plus F into W cos theta. Now what I will do, I'll divide this whole equation by W cos theta. Let me divide this whole equation by W cos theta. So when I divide this whole equation by your W cos theta, what will happen? This equation will change to what? Let me change this equation. Here you see there is P and cos theta. So when I divide by W cos theta, it will become P by W. And then less than equal to, this will become W sin theta by W cos theta. Sin theta by cos theta will be tan theta. So tan theta plus Fp by W. Fp by W. Then sin theta by cos theta is tan theta. Then plus Fw cos theta by W cos theta. I'll get what? Only F. This equation changes like this. And what I will do, I will take this term this side and I can take P by W common. So it will become what? You see, P by W 1 minus F tan theta, right? It will become P by W 1 minus F tan theta less than equal to, this is F plus tan theta. Let me just rewrite this equation. This will become, you see, P by W now less than equal to tan theta plus F by 1 minus F tan theta. Yes, you see, we saw this, we got this equation. Now see what happens here. You see, this F is already less. Yes, this F is already less. The F we have very less value actually. Yes, the F we are having very less value because F maximum value is 0.15. So it is very less already. And tan theta is also very less because tan theta is less. Why? Because theta won't be very large. Theta will be 3 degree, 4 degree, 5 degree like that. So it will not be very large 60 degree or 30 degree. So since theta is less, so tan theta is also less. So what will happen, since f is less and tan theta is less, when you multiply f tan theta, that will come very, very less compared to 1, right? It will come very less compared to 1. So I can ignore this. Yes, I can ignore this. Why? Because 1 minus f tan theta will come very close to 1 only. It will come 0.9997 or 0.9987. That is almost equal to 1. So this equation changes to, you see, P by W less than equal to tan theta plus f. Now see, we know what was our P. P was, centrifugal force was weight into V square by GR. So P by W will give me what? It will give me V square by GR. So now I can write down, you see, V square by GR is less than equal to tan theta plus f. Now let us go to the equation when the rod was not tilt. When the rod was not tilt, then what was the equation we are getting? You see, when the rod was not tilt, so at that time I was getting the equation that V square by GR is less than equal to f for no skidding condition. Now when the rod is tilted, now what I am getting? I am getting V square by GR is less than equal to tan theta plus f. So you see, this additional tan theta has come into picture. Yes, this additional tan theta has come into picture, which was not there before. So when we were tilting the rod, this additional tan theta is coming. You see, here only V square by GR is less than equal to f. Here V square by GR is less than equal to tan theta plus f. So this additional tan theta, which helps in countering the centrifugal force and making no skidding condition more strong. And this tan theta is known as what? Your E super elevation. This tan theta. So when you are tilting this rod like this by some angle theta, so the tan theta is known as what? That is known as E, and that is what? The super elevation. So this tan theta is the super elevation. And if you are seeing the equation of super elevation, what we will get? The equation of super elevation. If I am seeing the equation of super elevation, it is E plus F. You see, this is E, this is F. E plus F, this is less, this is greater than equal to, I can make it equal to in the limiting condition. So this becomes equal to, you see, this becomes equal to V square upon GR. So this is the equation of super elevation I am getting. This is the equation of super elevation I am getting. Now see here what happens here, you see. Now this V is in meter per second. So when I make it square, so meter square, second square. Now G is acceleration due to gravity, that will be meter per second square. So this will be meter per second square. Now this radius will be in meter. So meter square get cancelled, second square get cancelled, and this is unitless. This quantity is unitless. Now see, this V is in meter per second. This V is in meter per second. Now suppose I am having speed capital V in kilometer per hour. We know that if you want to convert kilometer per hour to meter per second, what we will do? We'll multiply 5 by 18. Why? Why so 5 by 18? Because you see, 1 kilometer is 1000 meter, 1 hour is 3600 seconds. So this is, if I'm dividing by, I'm cancelling this 0, I'm dividing by 2, from 5, this will become 18. So when I multiply 5 by 18 with this, when I multiply 5 by 18 with the speed in kilometer per hour, I get the speed in meter per second, right? So what I can do is, in this equation, in place of this, your small v, which is meter per second, I can use what? 5 by 18 capital V, where capital V is in kilometer per hour. Okay. Then what I will do, I'll put this value of G, which is 9.81. So now if we rearrange this, it will become, you see, V square divided by, it will be 18 square into 9.81 divided by 5 square, this 5 square will go down, same thing. Now this value is approximately 127. So IRC 73, which is the code for your geometric design of roads, changes this equation to what? V square by 127R, right? It changes the equation to V square by 127R. So if you are seeing the equation of theoretical equation of super elevation, so what we get? We get E plus F is equal to V square by GR. You see this small v is in meter per second and radius is in meter, or I can write down this as capital V square by 127R, but R still remains in meter, but this capital V is in kilometer per hour. So either you using this equation or this equation will get the same value. So this is the equation of your super elevation. Yes. So this is the equation of the super elevation. Now there is some IRC recommendation in this, which is very important, and we should know that. What is the IRC recommendation for this equation? You see, IRC, which IRC? This is IRC 73. Now what is IRC? IRC is Indian Road Congress. IRC is Indian Road Congress. IRC is Indian Road Congress. It is responsible for, Indian Road Congress is responsible for what? For the designing all the specifications for highway construction or highway geometry design, pavement design, traffic engineering, all those things. So in this 73 is the code for geometric design of roads. Okay. So as per this, what is the recommendation? The first recommendation is that friction is assumed not to develop. Okay. That why it is assumed not to develop? Because I have told that we cannot trust this friction. This friction might develop, the friction might not develop. We cannot trust this friction. Okay. So in this equation, E plus F is equal to your V square by 127R. We cannot trust this friction. So therefore, IRC recommends that while we are designing the super elevation, we don't take the friction into consideration. So we are taking this F is equal to 0 here. Okay. Then what is the second recommendation? The second recommendation is that we will design for 75% of design speed. Okay, we'll design for what? 75% of design speed. 75% of design speed. Yes. So now 75% of design speed means what? 75% of design speed means what? So in this equation, if you see, the original equation is what? E plus F is equal to V square by 127R. So first thing we told that this F is 0, right? The first thing we told that this F is 0, this friction is 0. Okay, because that is the assumption, that we are assuming that friction is not getting developed. And second is that we are designing for 75%. 75% means what? It will become 0.75. 75%, or I can say 3/4, right? 75%, or I can say 3/4 of the design speed. So 0.75 V square. This equation will change to, you see, this will become V square by 127. Then this 0.75 square will go down R. So this equation becomes approximately equal to V square by 225R. It will become approximately equal to V square by 225R. So now as per IRC recommendation, what is the changed equation? E is equal to V square by 225R. So this is the equation as per IRC. This is the equation as per IRC, and this is also known as for mixed traffic conditions. Why it is known for mixed traffic conditions? Because why it is called for mixed traffic conditions? Because on the highway, the vehicles will be traveling with different speed, right? The vehicles will be traveling with different speed. So this is known as what? For mixed traffic condition. Mixed traffic condition means that vehicles are traveling at different speeds. They're traveling at different speeds. Okay. So now this is the as per IRC. Now there is another recommendation from IRC that whatever E we are getting, this should be less than a maximum value. Less than what? Less than some maximum value. Now what is that maximum value? That maximum value is 0.07 or in percentage 7%. Now this is for which type of terrain? For plain or rolling terrain, right? For plain and rolling terrain, we have 0.07 or 7%. Now, we have another type of terrain, that is what? Mountainous terrain and steep terrain. That will be hilly terrain, right? So this is 0.1 or 10%. This is for mountainous or steep, or in combination I can say what? Hilly terrain. Now, if it is not mentioned in the question that it is hilly terrain or plain terrain or rolling terrain, we will always assume plain terrain. So, if it is not mentioned in the question, we will always assume what? Your plain terrain. So, let us solve a few questions. Let us solve a few questions so we get an understanding of what type of questions they will ask in the examination. Let us solve a few questions. You see, this question you see, what is written here? A two-lane highway is to be designed with a horizontal curve of radius 320 meter. The design speed for the road is 65 km per hour. As per IRC recommendation, determine the required rate of superelevation. As per IRC it is written. So what we will do, we'll use the equation E is equal to V square by 225 R. This will become equal to what? The speed is given, you see, 65 km per hour. So 65 square divided by 225. The radius of the curve is given 320. I'll use this 320. So how much value we are getting, you see? 65 square, 65 square divided by 225 divided by 320. I'm getting a value of, you see, 0.0586. Now, once you get this superelevation, you should check with the maximum value. Now, nothing is mentioned in the question, so we'll assume what? Plain terrain. As I have told, if nothing is mentioned in the question, we'll assume what? Plain terrain. So, as per that, what is the maximum value? The maximum value is 0.07. We have just seen here, you see. The maximum value of E is how much? For plain terrain, it is 0.07. Now, the superelevation you are getting 0.0586, it is less than this 0.07, right? It is less than this 0.07, which is the maximum value. That means whatever value you are getting, it is fine. Yes, it is coming less, so it is fine. So I can say this, if we round, it will become what? 0.059, or in percentage, what I will do is multiply 100 to this. So this will become 5.9 percentage. It will become 5.9 percentage. So right answer is option C here. Right answer is option C. So very straightforward question. Very straightforward question. Let us solve another question. Let us solve another question. You see here, what is written? A highway curve has a radius of 270 meter and design speed of 72 km per hour. Find the rate of superelevation to be provided as per IRC guidelines. So here again it is not mentioned. So what we will do? We'll assume plain terrain. We'll assume what? Plain terrain. And here, if we use this equation, you see same equation, E is equal to V square by 225 R. So what will happen? This will be equal to V is your 72 square divided by your 225. Then R is how much? R is given 270, right? If you calculate this, how much you are getting? 72 square divided by 225 divided by 270. So I am getting a value of, you see, 0.08. I am getting a value of 0.0853. I right? I'm getting a value of how much? 0.0853. Now, since we have assumed plain terrain, so in this case, what is the maximum E? The maximum E is 0.07. Now, the value which we are getting, it is coming more than the maximum value. So whenever you are getting E more than the maximum value, you have to restrict the E to that maximum value. So in this case, what will happen? This E will be equal to E max, that is equal to 0.07. You have to limit this E to the maximum value, and that will be equal to how much? 0.07, or I can say 7%. So here the superelevation will be how much? It will be 7%. It won't be this 8.53, because you see you're getting 0.0853, which is 8.53 percentage, but that won't be right answer. Why? Because here it is coming more than the maximum value. In the previous question, yes, you see you're getting less than the maximum value, so it was fine, right? In the previous question you're getting less than that, so it was fine. Let us solve another question. This is another question, interesting question. You see this, what is written? A vehicle is traveling at a speed of 75 km per hour. The horizontal highway curve with radius 250 meter. It is written the developed lateral friction coefficient is given and the required rate is given. Now here you see it is not H per IRC. Here they have not asked the question H per IRC. You see the previous two question, they have mentioned IRC, right? H per IRC recommendations. Here, H per IRC. So it was mentioned IRC. But here it is not H per IRC. First thing, it is not H per IRC. And then it is written friction is developed. Yes, what is written? If the developed lateral friction coefficient that is given. If you remember that H per IRC, friction don't get developed. So since it is written that is development of lateral friction, so this is not H per IRC. So when it is not H per IRC, which equation we will use? We use this equation, E plus F is equal to V square by 127R. We'll use this equation of E plus F is equal to V square by 127R. So when it is H per IRC, see, when we are solving H per IRC, then we'll use V square by 225R. But if it is not H per IRC, what is the original equation? The original equation is what? It is E plus F is equal to V square by GR. So from here, E will be how much? V square by 127R minus F. So see, V is how much? V is 75. So 75 square divided by 127. Radius of the curve is 250, and then we'll subtract this F, which is given 0.13. Let us calculate this. The 75 square divided by 127 divided by 250 minus 0.13. It is coming, you see, 0.0472. Now, when we are not doing H per IRC, there is no need to check it is coming less than maximum or maximum or not. Maximum thing is only H per IRC. So you need not check it is coming less than maximum or in this case. Okay. So it is coming, you see, 0.0472, which is this option B here, which is the option B here. So that means you see that we solve three questions. Now, whenever they mention IRC, then we are going to use the equation what? Your V square by 225R. Like we saw this question, you see. So when they are mentioning IRC, we'll use what? V square by 225R. There is no friction developed, and after finding the E, we must check with the maximum value. Okay, like we did here and we did here. The first two questions. In the first question, it was not exceeding the maximum value, so perfectly fine. In the second question, it was exceeding, so we limited to the maximum value. Now, if they are asking not H per IRC, not mentioning IRC, and they are writing that friction is getting developed, then we use equation what? E plus F is equal to V square by 127R. So that is the whole thing about why in highway curves we tilt the road. Why we tilt the road? I have explained it earlier. Yes, if we go, let me revise this for you. That we tilt the rod. Why we tilt the rod? So that when we're not tilting the rod, there was only friction opposing this centrifugal force. But when we tilt the rod, there is W sine theta also. There is W sine theta also, and therefore the equation which we get is what? E plus F is equal to V square by 127R. Now this equation changes as per IRC by assuming friction to be 0 and designing for 75% of the design speed. The equation changes to what? B square by 225R, and then there is the concept of maximum superelevation as per IRC. Okay, and where to use which equation, that also we saw. Okay, now for more such sessions and concepts and notes, you can join this Telegram group. Okay, I have explained this concept. So for more things, obviously everything cannot be covered here. So for more things, you can join this Telegram group where I share more videos and more short notes related to this. And then based on today's class, I have a homework for you. Based on today's class, I have a homework for you. Yes, so this is the homework for you. So please solve this question, this homework, and mention the answer in the comment section. Okay, so please solve this question and answer in the comment section. Okay, what is your answer? I want to see that. So there should be what? Some homework also. So solve this question and mention the answer in the comment section. Okay, and let me summarize. So we saw why we need the superelevation, why we are tilting the rod to counter the centrifugal force. Then we saw this equation, E plus F is equal to what? V square by 127R. Now this we use when there is development of friction. Then H per IRC, we use E is equal to 225, and this superelevation less than is equal to maximum value, that also is as per IRC. So thank you very much. So please solve the question, the homework question, and mention the answer in the comment section. So we'll come up with some more concepts in the next class. Thank you very much. Thank you.